Okay, this is 2006 Form B, question number 3, and here we go. Three electric charges are arranged in an XY coordinate system as shown. Express all algebraic answers. The following parts of capital Q, lowercase q, x, which is your horizontal distance, and d, which are your vertical distance, and fundamental constants. Don't forget k counts as a fundamental constant, just like g does. So it says on the diagram, draw vectors representing the forces F1 and F2 exerted on the little charge by the big Q charges. So we'll start with this one. This is a positive charge, and this is a positive charge, which means the force should be away because positives repel. And looking down at this, this is a negative charge right here. Well, that means a positive charge will be attracted. So for the first part, they should be equal size because the two Q's are the equal size and equal distance, and they should be attracting for opposite charges and repelling for negative. Okay, and part B says, determine the electric field, the magnitude, and direction at the position of the plus Q charge due to the other two charges. So basically, what we're looking for is the total amount of force that's acting on this object. So if you look at this, and you remember, you don't draw components when you draw these things, but if you look, the x component here and the x component here are going to cancel each other out, which are exactly the same. Now what doesn't cancel out is the vertical component downward here and the vertical component downward here, which added together give us our total force, which is this. So basically what we need to do is find the y component of one of these forces and then just double it. So in order to do this, you just plug in your information. First off, I know that F1 is going to be equal to F2 in terms of magnitude. And now I know that their y components are going to be equal. So if I can find F1, all I have to do is slap a 2 in front of it because there are two forces acting. So the equation for this is K Q1 Q2 over R squared. K can stay, but the Q's have to change. So this becomes K Q capital Q over, now my distance is the distance between these two charges. But if you look, I've got this side and this side of a right triangle. Well, that's just okay, that's just Pythagorean theorem. That's a squared plus b squared equals c squared, but then you take the square root. So I'm going to plug that in on the bottom. And don't forget to bring that square along with it. And you can see that this now becomes k little q big Q over x squared plus d squared. But you're not done yet. Don't forget that 2, by the way. We need to worry about the angle. Remember, we want a y component. And my y component here, well, I don't exactly know what that is. So what we need to multiply this by is the sine of theta right in here. Remember how we always do it to the horizontal? The sine of theta is opposite, which is d. So let me write this up here. So sine theta equals opposite, which is d, over the hypotenuse, which we already found to be the square root of x squared plus d squared. So if I want to multiply this whole thing by sine of theta, which I do to get the y component, all I have to do is replace sine of theta, because that isn't one of the things I can use, with what it is equal to. So my final answer all the way over here comes out to be okay, it looks pretty complex. You can actually simplify it a little bit, but there's no easy simplification. You could simplify it to 2kq capital QD over x squared plus d squared, the quantity, to the 3 halves, but there's no need to do that. Okay, so that was it for finding the force. Now, letter C says, well, now we have to determine the electric field magnitude and direction at a position of the positive Q charge due to the other two charges. Well, that's really not a bad idea to just, I guess a pen couldn't hurt. E is equal to F over Q, right? Well, that's not a problem because last time we solved F, we got that huge long thing over here. So basically, you're going to take this whole thing and you divide it by Q. Well, what are you left when you divide it by Q? You basically just lose your Q. So my electric field is 2K capital Q D over x squared plus D squared times, and once again, you could simplify that to the 3/2, but that's up to you. Now, some of you might be worried that it says magnitude and direction, but we found out before that it was just pointed straight down. So you can just write down or the negative y direction. All right, part D says calculate the electric potential at the position of the plus Q charge due to the other two charges. Well, electric potential is also very kind because if you ever want to find electric potential, you really just add up the individual pieces. And I know the equation for electric potential is just KQ over R. And now you just replace it with what it's equal to. Now, in this case, we have one that is positive Q, and the distance, don't forget the distance we found is x squared plus d squared. Plus, and then the second one is a minus Q with the same distance. So what do you get when you add these two things together? You get the total voltage, 0 volts. Very happy coincidence. So force is really the nasty one of the bunch. Once you get past force, it's really not so bad. Sometimes. Okay, that'll do it for this problem, and I guess you'll move on to the next. Leave that up for you for a second.